Hello everyone. Like they said, today we're going to talk a bit about malicious plugins, more specifically in VS Code. I wanted to start this talk just asking a little bit of a general question. Who here uses VS Code? If you can just... Yeah, okay. And who here have heard about malicious plugins affecting VS Code? Okay. Oh, great to know. Well, today we're going to talk a bit about that and pretty much how easy it is to get some malicious plugins into the VS Code marketplace and what Microsoft is doing or not doing to tackle those. So, like they said, I'm a security researcher at Checkmarks. I've been in security for about 5 years now. My focus is more on web, but for the past year and a half, I've also been focusing around supply chain security. And I pretty much like to hack shit on my free time. You have some of my links here. Feel free to add me after the talk. So, supply chain matters. This is the new OWASP Top 10 from this year. It came out just in the couple of weeks ago at the OWASP Global AppSec. And we can see there's a new topic here that jumped up to the third spot. And this one, if I'm not mistaken, got voted by like the users that voted on the polls. I think it was number 1 on the user vote for the most impactful thing that they could vote on. And that's software supply chain failures or software supply chain compromises, anything like that. This is something that was present before in other lists, but as a more general topic. From now on, it has really high spots and specifically talking about the software supply chain. So why do developer environments themselves matter? So developers have high privileged systems. If a developer gets compromised, their IDs contain sensitive credentials and all of the source code to the company. All of the development tools pretty much bypass some of the security controls. I don't know if anyone here has worked, for example, with EDRs on their computers. I figure most have. And I figure most of you haven't had a problem installing a plugin before due to the EDR. If I'm mistaken, please come talk to me afterwards. But from some of the tests that we have done, this hasn't been a problem yet. And a single compromised plugin can pretty much impact the whole ecosystem of the company. So if a single developer gets compromised, they are a high value target. They contain a lot of sensitive credentials and keys. Just a compromise of a single developer can lead to a bigger compromise of the whole company. So why VS Code itself? This is a stat from one of the latest, I think it was from Stack Overflow, one of the developer surveys that they do in a couple of years. And about 70% of developers said that they use VS Code. I think that's more or less also what I saw here. So I think that's pretty much accurate. Even if you don't use it daily, you most probably have it installed and have used it in some capacity over your work. Pretty much anyone can publish plugins. You can go from zero, no account created in any platform or anything like that, to having a published plugin in 5 minutes. It auto-updates by default, so if you publish a plugin and in 6 months you decide, okay, I want to turn it malicious, you just push an update and everyone gets your update. They don't need to opt in to the auto-update function. Trust signals are very flimsy, so I will enter in a bit more detail on what this means in a bit, but pretty much it's hard sometimes to know if what you're looking at is the actual reality of the plugin that you're installing. The plugins run with full ID privilege. So, for example, any access that your user has is the same access that your plugin that you're installing will have, because the ID is running with the same permissions as yourself. And it's not sandbox. So, for example, if you have any experience with browser plugins, those are sandbox, for example, or at least for the most part, for most of modern browsers. All of those are sandboxed. Here they are not. You contain a lot of hidden dependencies. So, plugins, like we'll see in a bit, they are JavaScript code. JavaScript code, you can have just any kind of dependency that you want. So, and any If you have worked with JavaScript before, you have your package.json, you just install any dependency that you want. And apart from that, on VS Code itself, you also have extensions that depends on other extensions. So that makes it a bit more difficult as well to know what you're installing. And it's just an open secret. So none of what I talk here is like something really novel. Microsoft doesn't really care. So, VS Code anatomy. So, what's a VS Code extension? It's pretty much, like I said, just a JavaScript project. It's just packaged as a .v6. That's pretty much just a zip file. If you have any kind of zip program on your computer, you can just right-click it and unzip it, and now you can see the whole code of the extension that you're installing. It's not really like obfuscated or anything, really just a JavaScript project. It contains a manifest, so it has your package.json, and it contains most of the fields that relate to some of the extension configuration, apart from also functioning like a normal package.json for a JavaScript project. So in this package.json, we'll see, for example, activation events, we'll see, for example, dependencies, and these include, for example, also extension pack and extension dependencies. For the triggers, some of the most common triggers are, for example, on startup finished and on language. These are, for example, most like common extensions that you can see. If they want to work like right out of the box and just get enabled automatically, they should use the on startup finished, which will just mean that as VS Code finishes starting up, the extension will activate. On language pretty much just means you can like configure for a given language, for example, for Python. If you install, for example, a Python linter or something like that, it will most likely trigger on language Python. Or, like we see on most malicious extensions, you can just put a star, and as soon as it's physically able to execute, the extension will execute. So VS Code doesn't even need to like finish its like starting up process. The extension will execute as soon as it's physically possible. For dependencies, we have a lot of different ways to do dependencies. I think most people are probably aware of this. You don't have to just use dependencies directly from NPM. You can, for example, also declare an dependency that's, for example, a GitHub project. Or you can declare an extension that's, for example, a URL. And on this URL, I've included this as more of like a curiosity. If anyone has any idea of what you can do with it, please feel free. But for example, in IntelliSense from VS Code, if you put, for example, the express and like declare a version, and you hover over the express, it will show you a bit of the description from the express file, like the express package. But if you put, for example, a URL, in this case, it's a URL that I bought, it's a Unicode URL with the different like R, it will also it will normalize the URL to Express.js, and then it will also like fetch the same description for the express package. So, moving on to extension pack and extension dependencies. What are these? So, it's pretty much just a way for extension developers to make it easier for users to install bundles of extensions. So if your extension depends on other ones, you'll just probably make an extension pack or an extension dependency, and when the user installs one, it will install all of the other ones. But what happens if we, for example, install by mistake an extension that it's an extension pack, and then we realize the mistake that we did, and we want to uninstall it? Well, for example, on an extension dependencies, when you install it, for example here, I installed this CMake extension, and in this case, this is my CMake typo squad extension. It will also install, for example, an editor config, the ESLint, and then my malicious extensions express session snippets. And we'll see in a bit what happens when we uninstall it. So, VS Code also has a couple of other interesting files that we can look at. For example, the extensions.json. So if you've worked, for example, with GitHub, you know, for example, of the .github folder. VS Code also has that. It has a .vs Code folder. One of the files there is the extensions.json. In the extensions.json, we can declare some extensions that you recommend to use when a user opens your project in VS Code. So when you open a project, you most likely have seen something like this before. So do you want to install the recommended extensions? And in this case, it's from Google and GitHub. And these are actual extensions from Google and GitHub, like you can see there. But what happens if we create an extension with just a different name, with a name that sounds, for example, like GitHub and Google? Well, do you want to install an extension from Microsoft, GitHub, and Google? for this repository, yeah, you can pretty much, when you're developing an extension, like I said, you can go from 0 to a published extension in 5 minutes, and there's pretty much no oversight. You literally just can't name it the exact same thing as the other one, as another publisher already exists. But you can name it, for example, Microsoft and Google. So, for publishing safeguards, this is claims that they've made. So they made claims that they do malware scanning, that they do dynamic detection, that they do unusual usage monitoring, name squatting, all of that. Well, pretty much on the malware scanning and the dynamic detection, I can say that if they do, they don't do a really good job at it. So, for example, on the typo squatting examples, you have the CMake extension, like the real one on the left, with 44 million installs, and my CMake typo squats on the right. If we look, for example, at like this on the web, if we look, for example, at the details of the project, we can see that something strange there. Like, if we look at the left one, which is the real one, compared to the right, we can see that it's pointing to the exact same GitHub project. It says that it's the same 6 pull requests, the same 77 open issues, even the version looks the same. But when we try to look a little bit more closely, we can see that the only thing that really changes are the release dates, the actual publisher, which also seems the same, also again the typo squads, and the identifier. But this just goes to show that, for example, you can just simply spoof the GitHub project that's associated with your extension simply by changing it in the package.json when you're uploading your extensions to the marketplace. They do 0 checks that the GitHub project that you put on the package.json actually matches the extension that you're uploading. So if you want, you can put just Microsoft there, VS Code itself, and it will mention that. So for some POCs of how easy it is to actually upload malicious extensions, for the first one, I had an idea. I wanted to do something that was malicious, but wasn't like a ransomware, because I didn't want to, in case anyone installs my malicious plugin, I didn't want to just ransomware their computer. So I thought about a simple info stealer that would call back to my own server with some username, the directory, the platform of the computer, all of this stuff. And I thought, hey, this can't be that easy, so I'll obfuscate it a bit. So I base64 encoded my payload, I put it inside an image, then from my the actual JavaScript code, I would fetch the base64 encoded string from the end of the image file and decode it and eval it. I upload this, it works, doesn't get blocked, I get my callback when I install it, everything fine. I was like, okay, looks like with some obfuscation I can get past this. Their defenses, their malware scanning defenses, or dynamic detection scannings. Well, so for the second one, let's do a second POC. For the second POC, I will just put my malicious extension in the dependencies. So how do the dependencies work? So when we install my CMake typo squad extensions, it will also install my Express.js session extension. When it's installed, it just once again gives me the callback. And in this case, when it's uninstalled, we can just see that the Express Session extension, it stays on the computer. So if, like I was saying before, if we install an extension that is an extension dependency, all of the dependencies, when you install the original one, all of those will stay on the computer afterwards. So unless you have some kind of logs for what you install, because my VS Code itself also doesn't log much, then you'll just have to look at all of your extensions and see what's misplaced there. And for the third one, I thought it can't be this easy, right? So I obfuscated, de-obfuscated all of my payloads. I just got all of the JavaScript itself, put it pasted it in the main function from the extension, all of the logic for calling back to my own web server, all of that, just pasted it right into the main function from the extension and try to upload it again. And yeah, once again, no pushback from the marketplace at all. It just goes right through, takes 2 minutes to actually pass some type of scanning that they do, and then it gets on the marketplace, you can install it, and I get a callback again. Although, I did get noticed, but not by Microsoft. when I was doing the presentation, the first edition of this presentation, and I was preparing the slides, I received an email that from someone in Poland, just a random security researcher from Poland that runs his own security scanner on the VS Code marketplace, and he found my extension. He looked at the IP that the extension was pointing to, and it was my own personal web server. And on there, I also host my own personal website. So there, you also had my email. So the guy went through all the trouble. He sent me an email. Hey, are you doing something on the VS Code marketplace? And we talked for a bit, and I just realized that, this guy found me, I think it was an hour after I uploaded this last version of my malicious plugin. The guy sent me an email within an hour of that upload. Microsoft took about, I would say 3 weeks to remove it. So, yeah. So in those 2 to 3 weeks, this is pretty much what happened. Once again, I didn't do any campaign to push my plugin, make it into more people's IDEs or anything like that. I just published it. And a lot of people, hey, that's the Express plugin. I think I'm going to install it. So, and the same thing for the CMake. The CMake is the typo squad, but yeah. So we have a lot of callbacks. More specifically, there were about 925 installs from about 300 unique IPs. A portion of these, not a lot, but a portion of these were security scanners themselves. I looked through the logs, and some of the logs that I saw, the working directory were something like SCS security scanner, something like that. So some of those were security scanners, but some of those were also things like people working on a robot operating system, or someone working on an underwater simulation program. And there were some other examples of this. Well, this, if I'm not mistaken, came mostly from the CMake typo squad extension. So a lot of the more impactful results that we got were from the typo squad, as people were trying to just type CMake and would make a typo. So how prevalent really is this kind of issue? So we can start looking, 2024, there were a couple of news reports, 2023, 2020 something for 2025, and 2025 as well. And especially Glassworm. I don't know if anyone heard about Glassworm here. Okay. So Glassworm was, I think, the most impactful malicious extension that we've seen so far on the VS Code marketplace. And it hits OpenVSX and the VS Code as well. But this is pretty much an extension that will replicate itself and will also embed into other kinds of marketplaces that you had. So it would steal some of your keys, it will steal some of your information, and then try to replicate itself through your account as well. These are some of the examples of real malicious extensions that we found in the wild. So for example, this is an example of a ransomware extension that when you installed it, it will request a URL from a remote endpoint. In this case, it would even do the distinction if it were a Linux or a Windows machine. And then when you installed it, it would ransomware your computer and ask you for Shiba coins to pay. The second case that I want to show is one of the more common plugins that we find, more common malicious plugins that we find, and these are around info stealers. I will have some more stats on the next slide, but these kinds of plugins are some of the more common ones that we find, and they're most of them rely around some kind of webhook trigger to send the information back to the attackers. In this case, they were trying to steal GitHub credentials. And in this case, they will send all of the stuff. I don't think you can see that up there. They would just send it to Discord. And Discord is the, I think, #1 most used form of exfil that we've seen so far in malicious plugins that we've found. For example, like I said, we have some stats. We've reported in the last more or less 4 months about 17 unique extensions. And these are split between the VS Code marketplace and the OpenVSX marketplace. From these ones, most of those, like I mentioned, are about data theft or exfiltration of some of sensitive data that you have on your machine. Some of these are downloaders or execution, like we had one ransomware, there were ones that I showed, and one just in-memory RC, they just like execute code and try to do a lot of shady stuff on your machine. A lot of the extensions that we've reported, they were like contained a bit. They weren't that popular, around like hundreds to a couple of thousand installs most, apart from one case that's still on like Microsoft's site for review, and they haven't answered us in about 2 weeks, which was an extension with about 1.33 million installs. And we're still waiting to hear back from Microsoft on that one. So about 8 of the extensions that we've reported, they were actually unpublished. And what does this mean? This means that we caught the extensions before they even got into the public eye. So when you're publishing an extension on the VS Code marketplace, you can actually choose to like leave it unpublished. So it's in the API, it's in their system, but it's not visible if you search for it on the marketplace itself. But we can still like analyze everything that's on the API, and that's what we're doing. So we're just analyzing everything, and 8 of the extensions that we found were still unpublished. One of those, between the time that we found it and reported, was like 2 days. It actually got passed from unpublished to published. So we can see that's something that attackers are doing. Like they just upload something, they make it unpublished, and then when they think the time is right, they publish it for everyone and then try to strike. So some of the most common patterns that we've seen here are pretty much like hard-coded HTTP endpoints. So either to exfiltrate something or to get something from there and like download and run it in the machine. A lot of those as well for exfiltrating, pretty much like most of them were Discord. I think I found a couple webhook.sites, maybe one Telegram, but mostly Discord. We had a couple like clipboard editor like stealers as well. So pretty much like if you open like any tab on VS Code, whenever you wrote something, whenever you copied, whenever you deleted something, it would just steal all of the like open context that you have and send it over the webhook to their exfiltration endpoint. Some download stubs and some of the takeaways that we can take here are just like, yeah, we can do like default denies to pastebins webhooks, but the attackers will just like get another way to exfiltrate the data. You can block everything. You can detect some rules. For example, if you manage some SIEM, if you manage like your EDR rules, anything like that, you could like look, for example, okay, the user just installed an extension and now it's pinging a random Chinese endpoint. I don't think that sounds like really normal. We can detect some patterns for that, for example, Discord, webhooks, or anything like that, and just curate an allow list of extensions. I will mention that in a bit, but that's pretty much the only way that you can really protect against stuff like this, is really with an allow list of extensions. So, when you actually remove an extension, where do they show up? So, this is just a repository that Microsoft has on the VS Code repository, and they have a file that's the removed extension from the VS Code marketplace. And here, whenever you report, like anyone reports something, or they themselves remove it, they add it to this file. They don't do really any like blog posts, they don't do really any posting, they don't like warn people, hey, we just removed this malicious extension. No, they just quietly add and like do a commit here, add a new line to the table, and that's it. So if you, for some reason, install the malicious extension, they would just like, after it got removed, they would quietly remove it from your ID as well, add it to here, and you wouldn't even know that you were affected by a malicious extension. How do other marketplaces fare? So Visual Studio suffers pretty much from the same thing. It's pretty much the same marketplace, the same everything, just like skinned differently. IntelliJ, it a bit better. Like they say they do manual verification for everything. I can say that's not really true, but it's a little bit better than VS Code at least. It's like not like as direct. You can go from 5 minutes like not having an extension to then having an extension published. We're still looking into other marketplaces, but these are the ones that we've looked so far. So, what's the official recommendation from Microsoft themselves? They say that you should look at ratings and reviews. That's like really difficult to fake, right? No one can just ask people to just write a review and give you 5 stars on your extension. They ask you to, hey, go to the Q&A. The Q&A is just a button that, once again, with the package.json, the GitHub repository, you can just put any link that you want there, and it will go to the link that you put there. So you can put, like, if you're using a typo squad extension, just put the link to the real Q&A there. Issues, repositories, and license, I don't think I even need to, like, really talk about that one. That's what we already saw. You can just put the real GitHub project there. And the verified publisher, which you would think this would indicate some more confidence on the publisher, but really it just means that the person that uploaded the extension bought the domain, because the little check mark there just indicates that they own the domain. So that's, yeah. So just to give a little bit of credit to VS Code, this is a post they made from some months ago, where they say they've slightly improved their detections for typo squatting, and I can say that's true. The first time that I did my tests with the CMake one were more than half a year ago. I tried doing them again more recently, it didn't work. And then they have like the future TM that they will do, which is like better copycat protection. So for example, the GitHub issue that I mentioned, like notifying users of potential extensions. So if you install an extension that's trying to like directly execute code, it will try to warn you. And just improving like publisher profiles and indicators that you can actually use to know that, hey, I'm installing this and it really is from who it says it is. So what should you do? Honestly, just common sense is not like, apart from not being that common anymore, it's not enough anymore. Like, there are too many ways to trick people into installing your extensions. There are too many ways to just trick developers. The best and only solution is really an extension allow list. So, do you think that would work though? This is some of the comments from a Reddit post that I saw discussing an extension allow list, where people were discussing like devs themselves. This wasn't like a security subreddit. This was just a dev subreddit. People were like outraged that someone would propose any kind of like developer restrictions on what they can or cannot install on their own machines. If you do want, I think there are a lot of defenders here, if you do want to like do something about this, you have the extensions that allowed field that you can configure organization-wide, and this does work. This is something relatively new. You didn't have this like a couple of years ago, but Microsoft has added it recently. And yeah, some of the questions that I leave to you here. Do you enforce like an extension allow list, and do you monitor existing people that are installing extensions for removed extensions? Well, just leave you with that. Thank you.
Thank you. Thank you. We still have a few minutes for a Q&A session.
Hi, thank you. Does the marketplaces like VS Code Marketplace and OpenVSC External are offering some reverse dependency API? Like I found this malicious extension, and I want to get a list of extensions that are using this malicious extension as a dependency.
Sorry, can you talk a little bit louder?
Oh, sorry. So are the marketplaces offering an API to get reverse dependencies?
The API? The API is shit. Like, honestly, it doesn't have like any official documentation for the API, so there was a lot of trial and error, and you can just request every extension pretty much that exists on the API, and it just has some flags that tell you if it's unpublished or not. And through that we can like know. You also have a couple more flags. For example, if for some reason they didn't remove the extension from the API, but they like found it malicious, they have one flag that's locked. So you know, for example, if a given extension is also like considered malicious by them, but for some reason they didn't remove it.
So as you showed, there are some extensions that do nothing malicious, and they hide the malicious content in a dependency. So if you find this malicious dependency, you have no way from the API to know which package is using
No,
this?
through the API you really can't. You actually have to download the extension and look at the package.json to see if there are any like associated extensions to that.
Okay, thank you.
No problem.
Any other question?
So you mentioned you get removed a lot of malicious plugins. So what's in it for check marks? I mean, you get money for subscriptions, not for doing that. So do you have an ID plugin also checking if you are using malicious plugins? Or
This is something that we're working on, so stay tuned in the near future.
Last one, maybe there on my right.
Very interesting. I'm one of the developers producing bugs and stuff. But if I want to have beta testers for my malicious plugin, can I use the guys that still commit the VS Code folder into a project to engage them using my plugin?
I'm sorry, I didn't understand the question.
If I create a malicious plugin,
Yeah.
can I use my colleagues who still commit the VS Code folder into a project to be my beta testers to install the plugin on their machine?
I think so. I don't see any, like, at least from the tested video, I didn't see anything that would, like, go against that.
Okay, nice to know.
Thank you and congratulations again for your talk.
Thank you.